Inverse trigonometry. All right. So we've talked about our regular trig functions. Those ones take in angles as input. They output either x or y coordinates on the unit circle or SOHCAHTOA ratios, depending on how you're looking at it. Inverse trigonometry, we're going to take it back to pre-calc 1 now, and we're going to talk about undoing a function, taking an x coordinate or a y coordinate or a ratio and turning it back into an angle. So you might remember from your pre-calc 1 class when we're talking about an inverse function, we use this notation. This guy right here is the inverse of the function f. And the idea of inverses is that they reverse or they undo a function. One of our classic examples of this is if you take the square root of x squared, this is equal to, well, it's equal to plus or minus x because of a strange range on the function x squared. But the functions square root of x and x squared are inverses of one another. There's a restricted domain thing that has to happen, and I don't want to get too much into that here, but these two functions are considered inverses of each other because they undo each other. In fact, if I restrict this range right here to just x greater than or equal to 0, taking the square root of x squared gets rid of everything, and now it's just x again. That same idea gets used in trigonometry of undoing a function. So square root of x can undo x squared, and ultimately we'll be using inverse trigonometry to undo trigonometry. There's a ton of different uses of inverse trigonometry. We'll be doing solving equations with inverse trigonometry. We'll be solving triangles using inverse trigonometry. There's a lot to be done here. So the notation we end up using for inverse trigonometry is the same kind of notation we did with inverses in pre-calc with this little -1 notation. So this guy right here is cosine inverse of x, sine inverse of y, tan inverse of y over x. This notation with the -1, that means the inverse. So it takes in an x value or a y value or a ratio, and it outputs an angle. For instance, I know that, let's say, I know cosine of pi over 4 is equal to square root 2 over 2, right? We have an angle as input. Boom, right there. And we have an x value as output. And indeed, if I scroll down here, right, the x value at pi over 4 is indeed square root 2 over 2. Right? So cosine of pi over 4 square root 2 over 2, you give it an angle, you get out an x value. What inverse trigonometry is going to allow us to do is we could say cosine inverse of square root 2 over 2 is equal to, and let me write down the question that's being asked here. What angle gives us square root 2 over 2 as the x value on the unit circle? That's the question that gets asked right here. What x value, because it's cosine inverse, what x value, or not what x value, what angle gives us the x value, square root 2 over 2, on the unit circle? And pi over 4 certainly works, right? Pi over 4 certainly works. Again, this is a little bit different now because you have x value input. And an angle output. The problem is, scroll back down to this unit circle down here, the issue we run into is, well, sure, the x value is square root 2 over 2 here, but it's also square root 2 over 2 down here at 7 pi over 4. And additionally, there are infinitely many ways for me to output square root 2 over 2 as the cosine value. I could just keep on adding 2 pi to any of these. I could say cosine of 9 pi over 4 is square root 2 over 2. So should not cosine inverse of square root 2 over 2 be 9 pi over 4? Should that not be true? I mean, if we think about what inverses do, this should be a true statement, right? But it's not. So we have an issue because we end up with this dual, we end up with infinitely many angles that can spit out the same values. And that means that we have to do some restricting of our domain, of our range, to tell these functions what types of values they can output here. We'll get into that more in our next video. I just wanted to go into the intro into this video. But we'll talk about these limited ranges in the next video here. A few notes that I want to make here. There's two different notations for inverse trig, and you're going to see both of them in Alex. So I'm going to talk about both of them here. I have a favorite. It's this one. This one's my favorite. But you'll also see arc cos, arc sine, arc tan. You'll see these ones here. These are the same thing. So sine inverse like this, arc sine like this, they mean the same thing. It's just different notation. The other thing I want to mention is that this notation is confusing. This notation is confusing because we know it's true that cosine squared of theta, that's the same thing as cosine of theta squared. Cosine cubed of theta, this is cosine of theta cubed, right? Cosine whatever power of theta should hypothetically be cosine of theta raised to that power. However, as it relates to this negative one here is this super special, and that negative one means that it's an inverse. It's not raising it to the negative one power, because x to the negative one is 1 over x, right? And this statement, cosine raised to the blank theta is equal to cosine of theta raised to the blank. This is true. And if both of these are true, it should reason that if you put a negative 1 here, that you could put a negative 1 here. And it's just not the case as it relates to inverse trig. Negative ones always mean inverses in trig, in this notation here. The last thing I want to say in this video, and I cannot emphasize anything more important than this next thing I'm going to say, is that inverse trig outputs an angle. You would be best off just repeating that phrase to yourself multiple times a day. Whenever you get bored, maybe repeat that phrase to yourself. Inverse trig outputs an angle. It's really important that you say this multiple times to yourself so that whenever you see an inverse trig, you realize this is an angle. If I look at cosine inverse of square root 2 over 2, I'm looking at an angle. I'm looking at an angle. Inverse trig outputs an angle. So that's the really big important thing. You'll be hearing me say that multiple times. Inverse trig outputs an angle. All right. So we're going to go ahead and we're going to get into the next video. We'll talk about the restricted ranges of these inverse functions a little bit more, because in order to make them into functions, there needs to be only one output per input. And right now, without any restrictions on it, cosine inverse of square root 2 over 2, it could equal pi over 4, it could equal 9 pi over 4, it could equal 7 pi over 4, right? If we don't restrict the range, the outputs, we'll have issues. So I'll see you in that next video. Bye.